Right, grade 10s. In this lesson, we're going to be focusing on another kind of geometry, which we call Euclidean geometry. Okay, Euclidean geometry. Now, I'm going to revise a few basic concepts from grade 8 and 9, and the one would be triangles. Let's just have a look at some properties of triangles quickly. Do you remember if that was little a, little b, and little c, which indicates, of course, the sizes of the angles, do you remember that a plus b plus c is 180 degrees? It's the sum of the angles of the triangle. If you add up all those inside angles, you get 180 degrees. Okay, then you have what we call an isosceles triangle. If you remember an isosceles triangle, if the two sides adjacent to each other are equal, then the base angles are equal. This is referred to as an isosceles triangle from grade 8 days. The base angles are equal. Equilateral, if you have an equilateral, all the sides are equal, so that's equilateral. And if you remember, all the inside angles added up to 180 degrees, but they were all equal, so they 60 degrees each. Okay, so those were some important principles of triangles that you needed from grade 8 days. Okay, now remember too, when you had parallel lines, do you remember the concept of F U N? Fun. Geometry was fun. If the lines were parallel, there were some properties that emerged from this little concept. The one, of course, were the two corresponding angles. So we spoke of corresponding angles equal if the two lines are parallel. What about this? This would be the alternate angles being equal, if you remember. If you've got the little n or z, and we can say that those alternate angles are equal. Also, if that was A and that was B, they're not equal, but A plus B is 180 degrees, and these are called co-interior angles, and they're supplementary. Do you remember that word? Co-interior angles are supplementary. They add up to 180 degrees. Supplementary, they add up to 180 degrees. Now I'm going to go and give you a little example, and we're going to look at this and revise all of these principles. Now in this little picture here, you've got two parallel lines, and what you need to do is you need to calculate the sizes of the angles indicated by all these small little letters here. Now, how do we do that? Well, let's see. If we've got two parallel lines, do you notice that that's 80 degrees given there? You've got a little n. Do you notice that little n, or the z if you like? And these are alternate angles. So little a would be 80 degrees. So we can say A is equal to 80 degrees because of the alternate angles being equal. All this grade 8 stuff is so important. Okay, so we've sorted out little a. Let's go to B. What do you notice? Look at this. There is an F. Look at that F there. Even though the F is sleeping at the moment, it's on its back, we can say that that angle equals that. So that is 80 degrees. And why? Because those are corresponding angles being equal, if you remember. All this geometry is going to affect you as we move on through the geometry this year. Okay, what about C? Aha, look at this. This is pretty cool. Let's go to green here. Notice here, this is the U. Can you see that U there? What a pleasure. There's a U. And those are co-interior, so this is 100 degrees. These two must add up to 180. So little c is 100 degrees. That's co-interior angles add up to 180 degrees, are supplementary. Okay, what about, let's have a look at another one quickly. D. Now what about D? Well, D is not a problem because this is an isosceles triangle, so little d must be 80 degrees. So D is 80 degrees, and why? Because that's the angles opposite equal sides. That's the isosceles triangle there, which of course brings us to E. Now why would E be 20 degrees? Well, think about it. E must be 20 degrees. Why? Sum of the angles of the triangle. In other words, if that's 80 and that's 80, that's 160. So you need 20 to make up 180 degrees. Sum of the angles of a triangle. Okay, what about F? Well, F, there's many options here that you could use. If you look at that, this is a straight line here. So you could say F is 100 degrees. Also, of course, these two are co-interior. There's the U. So you could say, but either way, let's use the idea of the, they call this, now watch this, this is adjacent, supplementary angles. The angles on the line. Adjacent means next to each other, and they are supplementary. They're on a straight line as well. You could have also said F is 100 from co-interior. This is all grade 8 stuff. Okay. And then G, well, if you think of G, that's 80 degrees because of the little Z there. Okay. Or you can, of course, use the idea of the straight line here. All of these three angles must add up to 180. But I'm going to go for the alternate angle approach. So G is equal to 80 degrees because your alternate angles are equal. There we go. So this is some basics from the earlier years. You're going to need these things when we do quadrilaterals this here. But the other important thing is congruency of triangles. Now, if you remember, before we actually get into some examples, there were 4 cases of congruency. Now, congruency of triangles implies this, that if you've got two triangles that are identical in size and shape, we call these congruent triangles. Okay. Now, there are 4 cases. If you can prove one of these cases, then you know that the triangles are congruent. The one case said if you can prove that a pair of corresponding sides are equal, in other words, that side equals that side, this side which corresponds to this side is equal, and these two sides are equal. This would be a case of a pair of sides, a pair of sides, a pair of sides, side, side, side. And if you can prove this in the two triangles, then you can say that the triangles are congruent. That would mean that everything about the triangles would be equal. All the angles, these angles would be equal, those angles would be equal, these angles would be equal as well, and all the corresponding sides are equal. The other thing would be if you've got two triangles here, and you've got a pair of corresponding sides equal, a pair of corresponding angles equal, and another pair of corresponding angles equal, you would have had side angle, angle, a pair of sides, a pair of angles, a pair of corresponding angles there. The other one was if you had two triangles like this, and you had a pair of sides, a pair of corresponding sides, and an included angle. The included angle was in between the two sides. That would have been side, angle, side. A pair of sides, and an included pair of angles between the two sides. Side, angle, side. The other one, of course, if you have a right angle triangle there, if you've got a pair of right angles being equal, the hypotenuses being equal, and some side, an adjacent side, or any side being equal, a pair of sides, it's right angle, hypotenuse, and side. Those are the cases of congruency. Now, what I want to do is I want to give you an example. Now, have a look at this triangle here. And I want you to, we're going to be proving, just as an example, that triangle ABC is congruent. Look at the notation there. That triangle ABC is congruent to triangle ADC. That this top triangle ABC is congruent to ADC. Now, what do we know? Let's have a look. This is how we set it out. We said in triangle ABC and triangle ADC, you wrote the two triangles down, and then what did you see? You could see that the length of AB in the one, the length of AB is equal to AD in the other triangle. That was given. Okay, the other little condition here you've got BC is CD. Look at that. BC is equal to CD, once again given. And the third thing, which is quite interesting about these two triangles, is they share, if you have a look at this, they share a common side. And so what we can say is we can say that AC is equal to AC, and that's a common or shared side. And then we could therefore say that therefore triangle ABC is congruent to triangle ADC, and we use the reason a pair of sides, a pair of sides, a pair of sides, side, 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 and the triangles are congruent. Okay, look at this example quickly. Another example, what I want you to do here is we're going to be, in this example, we're going to be proving that the left triangle, that triangle ABC, is going to be congruent or identical to triangle ADC. ADC, ABC, ADC. Okay. Now, how would you do this? Well, what do we know? We've got AB is AD, so that's a pair of sides. We've got the common shared side AC and the two included angles. So we could say in triangle ABC and triangle ADC, we could say, well, let's see A. We've got, I'm just going to move that up there. Let's have a look here. We've got AB in the left triangle equals AD in the other triangle, which is given. And then we've got A1, angle A1. Notice the notation. Angle A1 is equal to angle A2. The dots indicate that they're equal. That's given. And then the third thing we've got is AC is equal to AC. That is common. And if we've got that, we can say that therefore triangle ABC is congruent to triangle ADC. And what is the reason for that? The reason is side, included angle, side there. Okay, great. And by the way, another way that you could have possibly maybe even looked at it is, do you notice that these angles here, let me just rephrase that quickly. If you look at that, if I'm just going to go to a different color here, let's go to blue. That why are these two angles equal? Think about that. Well, because this is an isosceles triangle. So what you could have actually said there, another approach would be if you look at triangle ABC and triangle ADC, have a look at this. You could have said that, look, AB is equal to AD. That was given there. The other one you could have said A1 is equal to A2 given. And the third pair of angles could have been angle B is equal to angle D. What is the reason for that? Angles opposite equal sides. Look at that. Angles opposite equal sides. And you could have then stated that the triangles are congruent. Look at that. You could have stated that the triangles are congruent, and that would have been side, angle, angle. A pair of sides, a pair of angles, a pair of angles. There we go. What a pleasure. Okay, it's time for you to do a practice example. Have a go at this one. And I want you to use congruency to prove that we want to prove that AC is CE and AB is equal to DE. So all you've got to do is prove that the two triangles are congruent, and you've got the parallel lines there, the two sides equal. If you prove the two triangles congruent, you can immediately conclude that AC is CE and AB is DE. Give it a go and let's see how you do.